Yeah, good day everyone once again. We want to continue from where we stopped, which is to find the relationship between the length and period of a simple pendulum. Alright. A simple pendulum is a typical example of a simple harmonic motion. So, in order to construct a simple pendulum, we must have a pendulum bulb, a thread of observable length, and we tie it to a particular hinge point. So, by suspending it, it becomes a simple pendulum. And what are we trying to show tonight? We are trying to show that there is a relationship between the period of vibration of this simple pendulum and the length that is given to it. Take for instance, we have a simple pendulum constructed, that's the pendulum bulb, and the distance between this hinge point and the center of the pendulum is L. So when this pendulum is subjected to oscillation or vibration, it's going to have a period, that is the time to complete one cycle. It's called the period T. So this period, by mathematical proof, is equal to 2 pi into root this length divided by acceleration due to gravity. Now, don't forget, our aim is to find the relationship between this period and this length. In order to do that, we are going to make that length the subject of the formula in such a way that if we divide both sides by 2 pi, we are going to have 2 over 2 pi will be equal to root L divided by G. So in order to remove this square root, we are going to square both sides, and when we do that, it's going to give us T over 2 pi all squared will be root L over G, everything squared. So the square will cancel this square root, and we are going to have this as 2 square over 4 pi square is equal to L over G, that is the T squared, and the 2 square is 4, while the pi square gives us this. So you can see that we have been able to see T square over 4 pi square is equal to L over G. Now we can now make the subject of the formula to be L, and in that case we are going to cross multiplying, we have G multiplied by T square will be L multiplied by 4 pi squared. So you can see that we can now make L to stand alone by dividing both sides by 4 pi squared. So dividing both sides, or DBS, I shortened it as DBS, divide both sides by 4 pi squared. So DBSB means divide both sides by 4 pi squared. So that gives us GT squared over 4 pi squared is L 4 pi squared all over 4 pi squared. So 4 pi squared will cancel 4 pi squared, and we are going to have L to be equal to GT squared all over 4 pi squared. So you will see that we can have GT squared over 4 pi squared. So now the relationship between the length and the period T, we can achieve this by considering G and 4 pi squared as scalars, because they have numerical values. So they are constants, they have numerical values. So we can say L is equal to G over 4 pi squared multiplied by T squared. So because they have numerical value in this what is it called now, dimensions analysis, So this we have a number value, this is a number, this one is also a number, pi square, that is 22/7 square if we are to have it numerically. So by doing that, we can see that they will be dimensionless, such that L will now give us kt square. So this is a direct variation where L is now directly proportional to t square. So it can be concluded that the length of a simple pendulum is directly proportional to the square of the period. So that shows exactly the relationship between the length of a simple pendulum and its period. So I want you to like this video and share it as we continue in another session of our lessons. Thank you. See you.